at VDT. I'm with Matt Bishop, Managing Director, and we're going to talk to you about interior engineering and the holistic approach to fire, acoustic and seismic design for interiors. Morning, Matt. Can you tell us a little bit about why this topic is so important to you?
Yeah, for sure. So performance requirements, in a word. I am most worried about the overlapping and often conflicting requirements that need careful consideration across disciplines to get it right. And further than that, I'm personally passionate about how we can use technology to solve these performance requirements, overlapping performance requirements, and other similar problems in technology.
What are the performance requirements for interiors?
So interiors have three main performance elements: acoustic, fire and structural. And as we look at each one of those in turn, acoustic is well, mostly about stopping noise or reducing noise in a space to a certain level. And I keep going back to a wall as a key sort of element to describe interiors. And with acoustics, it's pretty simple, trying to stop sound from one room or one tenancy passing into another room. And looking at how the wall acts as a drum or as an absorber to stop that sound traveling through it. Okay, fire is similar, except this time it's not sound we're trying to stop traveling through the wall, it's fire, and giving the people in the other room enough time to escape. The key performance requirements for fire would be the insulation, the integrity and the structural resilience of that wall. That's your typical FRR rating, your 60-60-60 or 30-30-30 as it might be. And then the last performance requirement we're trying to balance here is the structural. And there's more than one element to structural. There's wind loading, there's soft body loading, which is when you come crashing up to a wall when you're playing a game of rugby inside or something like that. And there's seismic. And seismic's the one that we focus on the most, but it does cross over with the wind loading as well. And then there's two elements to the seismic loading. You've got the lateral acceleration itself, like the earthquake pushing sideways, but then you've also got how the building's moving with the earthquake as well, the difference between how one floor is moving and the next floor is moving. That's called interstory drift. And of course, there's not only walls that we consider with the interiors, there's also ceilings and plant and storage racking and things like that as well.
Awesome. So that's the three performance requirements separately. How do they interact together?
Often, the design intersection of those three performance requirements doesn't go all that well. This particular diagram here shows how three common design intersections work or don't work with the different performance requirements. So for example, a staggered stud wall is a great way to create an acoustic barrier. And you can also make it comply with fire, but it's horrible in the structural sense. You've got two sets of studs that are not connected to each other. The next one I've got there is a fire penetration through a firewall, say. Acoustic's fine as long as it's sealed up nicely, and it's designed to it's designed to stop the fire, so it's okay for that, but structurally it can be a problem. If that wall is going to move in an earthquake, it's likely that those surfaces are going to break the wall at that point, and then you lose your fire integrity as well. And then the last example I've got there is a standard structural detail, which is also fine for fire. However, if you make a nice strong structural wall, it tends to work poorly for acoustics. The stiffer the wall, the more sound it will transmit. So you can see there's a wee bit of a difficulty in getting those to work together.
And solutions, how do we go about fixing those sorts of problems?
Yeah, that's normally an area of several different responsibilities. So liabilities cross over, and a lot of these things get swept under the carpet when we consider our own individual responsibilities. While different professionals will use best practice, you won't, for example, see a fire engineer taking responsibility for firewall penetrations after an earthquake. There is some good ideas in this space, but it's definitely an area for development. I've outlined 3 here. There are ways you can do a deflection head track and a fire treatment. There's also a good concept around a split partition where you put services above the operable wall, and the services move with the floor above, the wall moves with the floor below. That prevents that issue with the fire penetration that I mentioned earlier. And then there's also some work with low damage partition design that is starting to get into the industry. However, most of those solutions do have a certain aesthetic consequence, which is hard to balance and hasn't really been balanced that well yet.
So fire, acoustic and structural performance, seems like a lot. Are there any other areas we should be considering?
Yeah, absolutely. The one that's become very hot this year is sustainability. What is the environmental performance or consequence of selecting different interior systems? And one big question that comes up there is what material for interior partitions and framing? Do you use timber? Do you use steel? That's a very heated argument at the moment, and only getting more so. Timber wins out on the embodied carbon when you consider the carbon requirement to create the timber or the steel. However, steel's got a good counter argument in full life cycle cost. Steel can be recycled infinitely, whereas timber is considerably harder to recycle. So it's an evolving debate, that one, but one thing that we do know for sure is that recycling, reuse and refuse chain management can be improved by using something called a materials passport. This is a pretty simple idea. It's basically a database of building elements and what goes into them, so that when it comes to demolition or it comes to refit, you're able to either reuse those components because you know what they are, or you can recycle them or dispose of them in the best way.
And how about the future, Matt? I know you're a technology activist.
You could say that.
What does the future look like for the AEC industry?
The AEC industry. So because we're all working in our silos across the industry, it's kind of hard to even see where the data flows, what technology could even do for us. I've had a crack at that. I've got this spiderweb diagram here, which tries to show the information and how it flows through the industry. And I've captured one of many different contractual frameworks that are used in the industry there, and even that's created quite a mess, to be fair. But there's opportunity there. You can see how the information goes through multiple different parties in multiple stages, and if we can get a bit of consistency there, we can do a lot more. But the question I like to ask is, if we could start with a blank slate, what could we do? If we reimagined the whole data flow, how could we create the shortest path between design intent and high performance construction? So if we look at that, and if we look at AEC, and if we look at the different roles and ways that people think, you can see that the architects are the home of creative thought and design intent. The engineers are linear analytical thought, analysis, planning, costing, and construction is highly agile thought. It's adapting to what happens on site, what happens with materials, what happens with labor to get the job done. So if you had to look at those 3 segments, and if you ask the question, well, which is the easiest to automate, which is the easiest to make better through the use of technology, engineering sticks out because of the linear analytical thought processes. Engineering algorithms enabling design intent, construction agility and compliance. That's pretty easy to see. So I can see engineering becoming more of an enabler for architecture and construction to pass at least the easy information straight through. And that's what we're working on at the moment. It's actually quite exciting. We've developed a platform called Penguin, which is a platform for the AEC industry to enable design and construction in the shortest possible path. And yeah, we're starting with interiors. That's our specialization, and we're rolling that out later this year.
Cool, thank you for that, Matt. And thanks everyone for tuning in. If you'd like to get in touch or find out a little bit more about what we do, jump online to our website at www.bvtengineering.com. Thanks.